Assalamu alaikum and a pleasant day, dear students. May I have the honor to introduce myself? I am Miss Norlailah and Madid, a faculty member from the Mathematics Department of the College of Natural Sciences and Mathematics of this institution, Mindanao State University, Marawi. Also, I am one of your CBP instructors for this summer academic year 2019-2020. Following this, I will be presenting your first video lecture for your CBP math class. Just keep on watching. For today's video lecture, we will be discussing some of the topics from Chapter 1, the real number system. These are the topics to be discussed from this chapter. First, we have a brief introduction to real number system, followed by the properties of real numbers, and lastly, the absolute value. So this is the first part of our discussion. In this part, we will be having a short introduction on the development of real numbers. Also, we will try to find out what are those numbers generated that made up this what we call the real number system. The story goes like this. Recalling the very first set of numbers that were introduced to us by our teachers or mentors during our kindergarten years or even our parents before we went to schooling, they taught us this set of numbers. Tinuruan nila tayo kung paano magbilang from 1 up to 10 and so on and so forth. These numbers are what we call the natural numbers or also known as the counting numbers. Tinawag rin siyang counting numbers because we use these numbers in counting objects or things. Like for instance in this illustration, if we were to ask how many stars are there, so basically to answer that question we need to use natural numbers. We have 1, 2, and 3, and that is why 3 is classified as a natural number or a counting number. Aside from that, they even use these numbers in solving problems that involves operations. An example of this is a problem which involves the operation addition, like 10 plus 7 is 17, and 17 is classified as a natural number. Another one is a problem with the operation subtraction, like 11 minus 5 is equal to 6. But as they went through knowing more about natural numbers, they found something unusual as they involve subtraction in subtracting numbers from itself, like 2 minus 2 is 0. So as you can see in the enumerated first 10 numbers below, 0 is found nowhere. In other words, 0 is not classified as a natural number. So napatanong sila, kung hindi natural number si 0, ano siya? Kaninong set ba siya belong? Anong pwedeng itawag sa kanya? And that's what motivates mathematicians to dig deeper on numbers to seek for an answer to that particular question. Finally, they came up with another set of numbers which includes the set of natural numbers and a 0, which they call the whole numbers. With this, they were able to answer questions like 2 minus 2 is 0 and 15 minus 15 is 0, and 0 is classified as a whole number. However, this didn't mark the end of numbers. They started to ask problems that involve subtracting bigger number from a smaller number like 8 minus 12, which is equal to negative 4. Kung titingnan natin itong set of whole numbers, walang negative 4. And that is why they studied again the numbers until they came up to a solution. They introduced another set of numbers which includes the set of whole numbers and its corresponding negatives, which they call the set of integers. Kaya nalaman nila na si negative 4 pala ay isang integer, specifically a negative integer. Another one is 0 minus 5 equals negative 5, which is also a negative integer. And 5 times negative 2 equals negative 10, which is again another negative integer. Akala akala nila okay na yon. Wala na silang problemang haharapin regarding numbers. But when they tried to involve division like 1 divided by 2 which is equal to 0.5, doon na sila napatanong ulit kung anong set of numbers na belong si 0.5. Kaya pinag-aralan nila ulit yung numbers until they got an answer to that question. At nadiskubre nila na there are infinite numbers between two integers that goes both to positive and negative side of our number line. They call these numbers as rational numbers. Rational numbers includes those terminating decimals like 1 divided by 2 is 0.5, repeating decimals like 1 divided by 3 which is equal to 0.3333 and more, and fractions like 1/4 plus 1/4 is 1/2. After this, they even introduced another set of numbers in opposition to rational numbers, at tinawag nila itong irrational numbers. Irrational numbers includes numbers that are not rational. In other words, numbers that are both non-terminating and non-repeating decimals like pi and square root of 2. And by combining all of these sets of numbers mentioned earlier, the set of natural numbers, the set of whole numbers, the set of integers, the set of rational numbers, and the set of irrational numbers made up the real numbers. This is an overview of what we were discussing about earlier. Again, real numbers are divided into two sets of numbers. We have the set of rational numbers and the set of irrational numbers. Recalling irrational numbers, again, these are any numbers that are not rational, which includes both non-terminating and non-repeating decimals. Examples of these numbers are shown. For rational numbers, this includes fractions and integers. Now, when we say fractions, these are numbers in the form p over q, where p and q must be integers. These numbers are also called non-integers. The examples are shown. Moving on to integers, these are divided into two sets. We have the negative integers and a zero and positive integers. Here are some examples of negative integers and another for zero and positive integers. We all know that this one is collectively known as the whole numbers, and the removal of zero or the positive integers alone made up the natural numbers, which is also known as counting numbers. In this part, we will try to represent real numbers using Venn diagram. So considering the set of real numbers as our universal set, we can find these two sets of numbers within the set, the rational and the irrational numbers. Within the rational numbers, we have the set of integers, and inside the set of integers, we can find the set of whole numbers, which contains the set of natural numbers. We are now on the second part of this video lecture. In this part, we will be discussing the properties of real numbers together with its corresponding examples for clearer elaboration. We firstly enumerate the properties of real numbers. First, we have closure property, followed by commutative property and associative property. Next in line is the existence of identity element, followed by the existence of inverse element. And lastly, the distributive property of multiplication over addition. For closure property, this is categorized into two, the closure property of addition and the closure property of multiplication. Masasabi natin na a certain mathematical statement emphasizes closure property of either addition or multiplication when the following are being satisfied. For closure property of addition, we have this one, and for the multiplication, we have this. This only means that when performing addition and multiplication of two or more real numbers, the resulting number must also be a real number. Here are the examples. First, we have 1 plus 3 is 4 and 4 is a real number. Observing this statement, it shows there that when we add 1 and 3, which are all real numbers, the resulting number is 4, which is also a real number, specifically a natural or counting number. And this statement is justified by the closure property of addition. Another one is 1/2 plus 1 is 1.5. It shows there that 1.5 is a real number. This is true, for 1.5 is classified as a rational number. So again, this is closure property of addition. Next example, we have -4 times 2 is -8, and -8 is an integer, specifically a negative integer. So this is closure property of multiplication since we use the operation multiplication in this statement. Same thing with the next example. 0 is a whole number. And since the operation used is multiplication, this is justified by the closure property of multiplication. Another one, we have square root of 2 plus 1. We all know that square root of 2 is an irrational number and 1 is a natural number. These are both real numbers. Consequently, the sum of these two real numbers is also a real number. To be specific, the resulting number is an irrational number. And noting the operation used, this is again closure property of addition. And lastly, 2 times pi. Pi is again an irrational number. The product of these two real numbers gives us another real number, specifically an irrational number. The operation used in this statement is multiplication, kaya this should be closure property of multiplication. The second property is commutative property. This is also categorized into two, the commutative property of addition and the commutative property of multiplication. So for this, we have this one for commutative property of addition and this one for the commutative property of multiplication. Observing these equations given by comparing the order of the variables a and b on both sides of the equations, firstly on the left-hand side, una si variable a tapos sinundan ni variable b. But looking at the right-hand side, nagkapalit ng posisyon si variables a and b. In other words, masasabi natin na it is in commutative property of either addition or multiplication if there is a change in position or order occurred. Moving on to the third property, we have associative property, which is also categorized into two, the associative property of addition and the associative property of multiplication. For this property, ito lang din ang pagbabasehan natin. For associative property of addition, we have this one, and for multiplication, we have this one. Kung sa commutative property, may change in position or order na naganap, sa associative property, change in groupings ang nagaganap. Kung titingnan natin, ang magka-group on the left-hand side of the equations ay si variables a and b. Pagdating sa right-hand side, si b at si c na ang magkasama. At yan yung ibig sabihin ng phrase na change in groupings. Here are some examples for the previously mentioned properties. First, we have this. Kung titingnan natin ito, ang pinakauna nating mapapansin ay yung pagkakapalit ng posisyon or order ni 1 and 3. In other words, may change in position or order na naganap. Kaya naman, ang tamang sagot for the property that justifies this statement is commutative property of addition, since it uses the operation addition. Second, we have this. Makikita natin na may groupings kasi may parenthesis na ginamit. Kaya doon muna tayo magfo-focus. Looking at this side, ang magkasama ay si y at z. Kung titingnan naman natin ang kabilang side, ang magkasama na ngayon ay si x at y. Ibig sabihin, there is a change in groupings. Kaya the best and correct answer for this is associative property of addition. For the next example, katulad pa rin ng ginawa natin sa previous example, yun din ang gagawin natin dito since may groupings tayong nakikita. For the left-hand side, ang magka-group ay si 2x at 3. Pagdating sa right-hand side, si 3 at y na ang magka-group. Ibig sabihin, may change in groupings. Kaya, associative property pa rin siya. But to be specific, it is associative property of multiplication, since multiplication na ang operation na ginamit sa statement. Next example. May groupings pa rin, kaya magfo-focus muna tayo doon sa groupings. Sa left-hand side, si 10 at 4a ang magka-group. Looking at the right-hand side, we see the same groupings. In other words, walang change in groupings na naganap, kaya hindi associative property ang sagot dyan. But let's observe further. Makikita natin na magkaiba yung kinalalagyang posisyon or nagkapalit ng posisyon or order si quantity 10 plus 4a at si 1. In other words, change in position or order talaga ang naganap. Kaya, commutative property of addition ang tamang sagot. And lastly, we have this. Mapapansin pa rin natin na change in position or order ang nangyari dyan. Kaya commutative property pa rin siya. But to be specific, commutative property of multiplication na ang tamang sagot since multiplication na ang operation na ginamit sa statement. The fourth property is the existence of identity element. This property is again categorized into two, the existence of additive identity element and the existence of multiplicative identity element. Let us first discuss the existence of additive identity element. In this property, 0 is used as an additive identity element which satisfies this equation. This means that any real number that is to be added to 0 will result to the number itself. For existence of multiplicative identity element, 1 is used as multiplicative identity element which also satisfies this equation. This also means that any real number multiplied to 1 will result to the number itself. In other words, there is a reflection of the number itself. The next slide presents examples for further discussion on the previously mentioned properties. For the first example, we have 0 plus 3 equals 3. This is an easy one for it comes in the same format to the one we have on the previous slide. That is this one. In other words, 0 is used as an additive identity element in this statement for it satisfies the shown condition. Hence, the property that justifies the statement is existence of additive identity element. Next, we have ABC times 1 is ABC. The property that justifies this statement can also be easily determined for it follows the same format with this. This also means that the number 1 in this statement is used as a multiplicative identity element. Kaya the correct answer for this is existence of multiplicative identity element. For the third example, we have this. We all know that 0 is treated as an additive identity element, but for this to be true, it must satisfy this equation. Observing these equations shown, do they come in the same format? Obviously, it's a no. This means the 0 in the given statement does not function as an additive identity element. Kaya hindi existence of additive identity element ang tamang sagot. But we all know that 3 and 0 are both real numbers. Therefore, the product they produce is also a real number, for 0 is classified as a natural number. Hence, the correct property for this one is closure property of multiplication. The next example happens to be in the same case with the previous example. In this, we can see the presence of number 1, and we all know 1 is treated as a multiplicative identity element if it satisfies this condition. Comparing these two equations shown, we can clearly see that the two are of different formats. In other words, the given statement does not satisfy the condition given. Hence, 1 is not used as a multiplicative identity element in the given statement. However, by further observation, we can conclude that the product of these two real numbers, 1 and 3, gives us another real number 4, which is specifically classified as a natural number. With this, we can say that this is justified by closure property of addition. And lastly, we have this. Kung titingnan natin ito, may groupings na involved. The numbers 2x, y, and z are grouped since naka-parenthesis sila. So in other words, pwedeng associative property siya since may groupings. But for this to be associative property, kailangan may change in groupings na maganap. Kaya let's observe first the groupings. Makikita natin na on both sides of the equation, we have the same groupings pa rin. Ibig sabihin, walang nabago sa groupings ng mga numbers na ito. Kaya, hindi associative property ang tamang sagot. Let's do further observation for this. We can see that there is the presence of the number 1. And we all know, 1 is used as a multiplicative identity element. Kaya posible na maging sagot dito is existence of multiplicative identity element. Pero para maging tamang hinala natin, this should satisfy this condition. Kung titingnan natin ng maigi, they come in the same format. For in the given statement, we can represent this one as the variable a. Sa madaling salita, 1 is used as a multiplicative identity element, kaya this should be existence of multiplicative identity element. The next property to be discussed is the existence of inverse element. This is also categorized into two, the existence of additive inverse element and the existence of multiplicative inverse element. For the existence of additive inverse element, we can say that the additive inverse of any real number a is negative a if it satisfies this condition. On the other hand, for the existence of multiplicative inverse element, we can say that the multiplicative inverse of any real number a is 1 over a, or also known as the reciprocal of a, if it satisfies this condition. Now, before proceeding to the examples for this property, let us firstly have a short discussion on reciprocals and additive inverses. Reciprocal is defined as this one. For example, if you were to find the reciprocal of 2, it says there that reciprocal of 2 is 1/2. And that is correct. Pero paano nangyari yun? We all know that all integers can be written in a fractional form where the denominator is 1. So in this case, since 2 is an integer, we can rewrite it in this form where its denominator is 1. Para makuha natin ang reciprocal ni 2, babaliktarin lang natin siya. Ang ibig kong sabihin, pagpapalitin lang natin ang posisyon si 2 at si 1. Si 2 na nasa numerator, dadalhin natin siya sa denominator. At si 1 na nasa denominator, dadalhin natin siya sa numerator. Kaya, nakakuha tayo ng 1/2 na siyang reciprocal ni 2. Another example we have, the reciprocal of 1/4 is 4. So again, katulad pa rin ng ginawa natin kanina, pagpapalitin lang natin ang posisyon si 1 and 4. Si 1 dadalhin natin sa denominator at si 4 dadalhin natin sa numerator, which gives us 4 over 1 or 4. Last one, we have negative 2/3. Kung mapapansin nyo doon sa previous examples natin, positive si 2 kaya ang reciprocal must also be positive. Si 1/4 positive rin, kaya positive rin dapat ang reciprocal. This simply means that in this example, since negative real number yung binigay, dapat negative rin yung reciprocal. So again, para makuha yung reciprocal ni negative 2/3, we will do the same thing. Si 2 which is originally nasa numerator, dadalhin natin sa denominator. At si 3 na nasa denominator, dadalhin natin sa numerator. Kaya mayroon tayong negative 3/2 na siyang reciprocal ni negative 2/3. For additive inverse, we have this definition. Ang tandaan lang natin, ang additive inverse ay opposite ng number. In other words, kung positive yung given number, ang additive inverse niya must be negative and vice versa. Here are examples. For the additive inverse of 2, we have negative 2 since the given number 2 is positive. Kaya dapat ang additive inverse niya ay negative. Next, si 1/4. Since positive si 1/4, ang additive inverse must be negative 1/4. And lastly, negative 2/3. Negative yung given number kaya si reciprocal must be positive 2/3. In this slide, we are going to present examples for the properties discussed earlier. But before that, let us first recall the existence of inverse element. For the existence of additive inverse element, we have this one, and for existence of multiplicative inverse element, we have this. Pakitandan lang po yan, for we're going to apply that later as we move to the examples. For the first example, we have this. Observing this given statement, we can see that negative 3 functions as an additive inverse of 3, or we can also say that 3 functions as an additive inverse of negative 3. Hence, this statement is justified by the existence of additive inverse element. Second example, we have this. Similar to the first example, makikita natin dito na si 1/5 functions as the reciprocal of 5 and vice versa. Therefore, the correct answer for this is existence of multiplicative inverse element. For the third example, there is no inverses present in the given statement. Therefore, existence of inverse element is not the right answer for this question. However, we can observe that there is a reflection of 3 on the other side of the equation. This means that 0 is used as an additive identity element for this item, kaya ang tamang sagot is existence of additive identity element. Next, we have this one. For this item, we can easily observe the presence of multiplicative inverse element or the reciprocal. Hence, this should be existence of multiplicative inverse element. For the fifth example, we have negative 2 times 1/2 is negative 1. Recalling what I said earlier in regards to the reciprocal of any number, I said that the given number and the reciprocal must be of the same sign. But observing the statement, kahit na alam natin ang reciprocal ni 2 is 1/2, it is still wrong to say that the reciprocal of negative 2 is also 1/2 kasi nga magkaiba sila ng sign. Dahil ang reciprocal ni negative 2 is negative 1/2. So, ibig sabihin, hindi existence of multiplicative inverse ang tamang sagot. Kaya, we will do further observation to get the right answer for this. We observe that the product of these two real numbers produces another real number. Therefore, the correct property that justifies the given statement is closure property of multiplication. And for the last example, we have this one. Observing the given statement, we see the presence of multiplicative inverse element. We have negative 5, which is the reciprocal of negative 1/5 and vice versa. Therefore, the right answer for this is existence of multiplicative inverse element. The last property is distributive property of multiplication over addition. Ito lang ang tatandaan natin para sa property na ito. We will start from this side of this equation. Ang gagawin lang dito to obtain the right-hand side is we're going to distribute the variable a kay variables b and c na nasa loob ng parenthesis. It goes like this. A multiplied to b results to AB, and then A will now be distributed to the variable C, which results to AC. So that is how this property works. We are now ready to present more examples for the properties of real numbers. First, we have this. Kung titingnan natin to, parang masasabi na natin agad-agad na distributive property of multiplication over addition na talaga siya. Pero hindi sapat yung feel mo lang. Dapat sigurado tayo. Kaya we'll try to get the right-hand side of the equation through applying the distributive property on the left-hand side. So firstly, we will distribute 2 to the numbers inside the parenthesis. We have 2 times x gives us 2x and 2 times y gives us 2y. This means this is indeed distributive property of multiplication over addition. For the second example, this is just similar to the first one, kaya the correct answer is still distributive property of multiplication over addition. For the third one, we see groupings, kaya doon muna tayo magfo-focus. Mapapansin natin dito na wala namang changes sa groupings, but the only thing that changed is the order or position of the numbers. Hence, this is commutative property of multiplication. Next example, in this illustration, we can firstly notice the presence of additive inverse element. Therefore, this is existence of additive inverse element. Moving on to the next example, we have this one. Observing the statement given, specifically the groupings appeared on both sides of the equation, there are changes. Ang magka-group sa left-hand side is si 5 plus D, while on the right-hand side, si 8Z plus 5 na ang magka-group. In other words, may naganap na change in groupings, kaya associative property of addition ang tamang sagot. Lastly, we have this. In this example, we can easily notice the reflection of the number 1 on the other side of the equation. This simply means 0 is used as an additive identity element, kaya ang tamang sagot is existence of additive identity element. Finally, this is the last part of this video lecture. In this part, we're going to tackle about absolute values. The absolute value of any real number depends on these following cases. For the first case, we have this one. This is only applicable when the given real number inside the absolute value sign is positive. Ang tandaan niyo lang, kay first case tayo magbabase kapag ang number na nasa loob ng absolute value sign is positive. Then, to get the result of the absolute value of that positive number, you're just going to copy that number. For second case, ito naman ang pagbabasihan natin kung 0 ang nasa loob ng absolute value sign. This means that the absolute value of 0 is always 0. And lastly, the third case, this shall be applied when the given real number is negative. This means that the absolute value of any negative real number is the negative of that number. Here are the examples. For the first illustration, this lies on the first case, since 26 is a positive real number. So obtaining its absolute value shall result to that number itself. The second one lies on the second case, since we are just asked to get the absolute value of 0, which is, we know it is always equal to 0. And for the last one, this lies on the third case, since negative 5 is a negative real number. Following what states on the third case, the absolute value of negative 5 is positive 5. It goes like this. Since we are on the third case, negative 5 shall be represented by the variable a, as it shows on the third case I mentioned earlier. Following the formula given on the said case, we have this one. Finally, negative times negative 5 gives us positive 5.